Indian Military Review, and the Center for Joint Warfare Studies organized a 2-day webinar and virtual expo on night vision and electro-optics India on 16 to the 19th of January 2021 for the Indian Armed Forces, Paramilitary Forces and Industry. The event covered thermal imaging, image intensifiers, infrared detectors, surveillance and reconnaissance, laser rangefinders, weapon sights, integrated helmets, periscopes and masts, NVDs for platforms, binoculars, goggles and monocles, and fire control systems. The Director General of Infantry, Director General of Capability Development, the Director General of Armored Corps and the Additional Director General of the Army Design Bureau were among the distinguished speakers. There were 7 sessions over 2 days and the video recording of the proceedings were rebroadcast over the next 2 days.
So are we a go, sir?
Yes, sir.
All right. So I will now start this session on emerging technologies. Jan Srivastava, Jan Arora, and my fellow esteemed panelists and all those who have logged on to hear this session on emerging technologies. My greetings to you and to my greetings to all of you from the Indian Army. At the onset, I extend my compliments to the Team St. George IMR for organizing the seminar on night vision and electro-optics, and thank all of them for inviting me to chair this session on emerging technologies. I also welcome my fellow panelists from the DRDO, Dr. Ranjana, and from the industry. I've met a few of you, and I look forward, and I know, having met you, that we are going to have a very engaging session over the next 1.5 hours. We just heard the DG/CD and DG Infantry speak in the inaugural session on how conflicts will increasingly leverage technology and the impact of technology in all facets of the battlefield. It is important for us to develop indigenous technologies in the field of night vision and electro-optics for our ISR needs. There is no denying that particular fact. The emerging battlefield environment is going to be dynamic, multidimensional, and technology intensive. It's going to be characterized by enhanced battlefield transparency and, of course, real-time connectivity. So as the warfare is becoming multi-domain, maintaining a technological advantage across key capability areas will be extremely critical for all of us, especially in the armed forces. So the emerging technologies present us these new opportunities and will change, I'm quite sure, the character of warfare as we see it today. Today, they are being realized as the core strength of any modern military and are receiving our concerted attention too. The Atlantic Council report on emerging technology states that the geopolitical shifts are going to accelerate the rate of innovation in the fourth industrial revolution technologies. In the same reframe, the NATO Science and Technology Trends has stated that over the next 20 years, 4 overarching characteristics can be expected to define many key advanced military technologies. That's intelligent, interconnected, distributed, digital. And the interplay of all these 4 is what is going to define a new technology. It is interesting that today we are deliberating an important aspect on these characteristics, that of enhancing our night vision and night fighting capability for future battles through development in optics for our surveillance needs at both the tactical, operational, and even at the strategic level. The technological aspects will be adequately dealt with in this forthcoming session by the experts that we have both from the industry and from the most premier R&D institute, that is the DRDO itself. So I'm not going to touch upon the technologies that are going to be used. As Army Design Bureau representing the Indian Army, I will speak from the perspective of the developing emerging capabilities, which we are in the process of by imbibing an innovation culture for harnessing these technologies and building an effective service industry academia interface in the particular field of night vision and electro-optics. In last year, the chief, while speaking at a similar seminar, highlighted the impact of technologies in warfare and emphasized that the Indian Armed Forces need to pay emphasis on technologies that have dual use and are being driven by both commercial entities and also innovation. So we here are trying and striving to achieve this into our modernization drive. The increasing pace of this technological development presents a great challenge to us for obvious reasons. We have rising costs, inadequate budgets, especially more so with the pandemic having overtaken us, and of course, dual-use civilian technology. So most of these emerging technologies are probably in a tremendous amount of research that is taking place in the industry, small firms, civil sector, and our universities. And we need to integrate the industry and the academia with the armed forces so that we are able to enable the civil-military fusion for core development of dual-use technology. Now, we heard Colonel Kuber, it's always a pleasure listening to him, putting into perspective the developments in this field and how it can actually enable the armed forces. His insights are always candid, relevant, and obviously to the point. I am really looking forward to reading the report that was launched in the last session and iterating some of the contents of that report with him and the industry to see if we can align ourselves into what is currently ongoing in the research and development field, as also in the design and development field with the industry. All the regular procurement schemes have been covered earlier, be it night sights, be it optical devices. Let me draw your attention to certain more recent developments and see if we can align this session towards those. The acquisition of aerial tactical ISR capability by the Army, and that too from an Indian entity, has been in the news over the last 2-3 days, and I'm quite sure you all are privy to that. Certain evaluations as we speak of optical and surveillance devices are ongoing, and we will hear that in the forthcoming days too, and all from the indigenous industry, and that's amazing. You all saw the swarm drone demonstration yesterday, which shows the intent of the Army to be contemporary and exploiting the available technology and leaving no stone unturned to ensure that the indigenous industry develops those technologies for us. I must confess, in the Ideas and Innovation competition, which the Army Design Bureau held about 2 days back, and which was witnessed by the Chief of Army Staff, the academia, the members from the R&D, DRDO, a large number of solutions developed by our own service innovators were targeted towards enhancing our ISR capability. We're also working with the IITs and some amazing startups, especially in the field of low light sensors, which can actually revolutionize the night vision industry. And many projects are also forthcoming through the tie-up with the startups and via the IDEX route, like the foliage penetration radar, for example, as was mentioned in the last session. So yes, things are really happening in this field, and the Indian Army assures you that we would be very, very forthcoming to handhold any development in this field. We heard the DGCD speak on the empowerment committee, which was set up to work out a roadmap for our night enablement and how our requirements in the image intensifying devices field was largely being met through the DPSUs and OFP. And I must put it on record that a task that they have rendered with absolute professionalism. So there's no denying the fact that when we required it, it was them who stepped forward to give it to us. But now the initiatives of the government and the Army towards getting the industry, academia, R&D establishment, and startups together has started bearing fruits. And I'm quite sure that is the area that we will see our technological needs being met in the future. So we, of course, have been in touch with all the innovators, industrial houses, and budding entrepreneurs in the exercise that Army Design Bureau is on it 24/7. A lot has been done, but the work is still obviously in progress. We here understand that uncertainty is a key characteristic of technological change, and the process from the emergence of a technology to its having an impact on military capability is a long one. So it requires experimentation. We may have a lot of failures, but we need to incorporate a greater appetite for risk-taking into our innovation pipeline. So we have initiated focused outreach programs with industry, academia, and significant progress has already been made. Let me assure you that the armed forces are taking the lead in supporting indigenization of night vision, electro-optics, and well, we have been reaching out through various forums, and the forthcoming Aero India also, this would be one of the focus areas that we will be looking at. But let me talk a little about the research and development field. We really need to bring down the life cycle costs of NVDs and battlefield optical equipment through R&D efforts by focusing on indigenous private sector partnerships and a civil military fusion. My travels have taken me to Bellops, Tata, Stonebos, and when I was conferences, it was heartening to see the commitment and fire with which research and development is being carried out, be in the field of see-through armors or the night sights or fusion technologies. So there's some amazing work that is happening out there. So the time now is apt where we need to augment the private sector, I think, with and facilities to make them the starting blocks of R&D. And I think that we in the services have the work cut out for us. It may not be a bad idea to follow a consortium approach one day, wherein development of future technologies are incubated, developed, and manufactured with clearly defined relationships with the industry. I think that is the area that we need to work upon more. We need to have a dedicated capability from the trial services, DRDO, academia, industry, think tanks, like St. George, who will crystal gaze and identify which emerging technology in the optics domain can impact warfare and is worth investing in. And I think this is one of the key takeaways from this seminar. We are aware that we cannot plan in isolation of the availability of resources. We all know that we are part and parcel of a democratic system. And we need to have a clear policy to meet a technology development cost within our timelines, resources, and budget. If the desired capability is not being met at an affordable cost, then it is time to think the emerging technology concept, because cost will always be the limiting factor. So to remain ahead of the technological curve in the desired time frame, probably that's the approach we need to look at. I would also exhort the industry to show more leadership in driving the Team India approach, which also needs more encouragement, of course, from the services. So the best and the best, the big boys of the industry are also on board today. And my reach out to them is that, yes, tremendous work is being done, but we request you to focus more on research and development, have dedicated R&D test beds in the field. That would be something that we are looking at so that we can facilitate your R&D. So towards that end, I think there is a tremendous opportunity here. The rate of change places a premium on agility and responsiveness of the defense acquisition system. So probably there is a need to gravitate towards an open model of defense innovation and faster infusion into the services without being bound by processes. But then at the end of the day, having said that, there is no denying the fact that the processes do bring in certain amount of transparency and accountability and are required. But yes, we need to look at ways of faster procurement. Even our modernization strategy for emerging technology needs to focus more and more, especially in this field of night vision and electro-optic industry. It has been a quintessential problem of what's lying over the hill. So we totally agree on that account. So as we modernize, we will embrace these technologies, recognizing that it will be their application that will have the disruptive effect that we need, be it airborne, aerial, be it drones, bots, big weapon platforms, near space UAVs, pseudo satellites. So be it the field, at the end of the day, the whole sole aim is to have real-time ISR and surveillance capability. Predicting changes will be challenging, so we will have to take the risk and accept some failures. Risk aversion is going to tie up our resources, talent, time, and money. So if we remain cautious and proceed until apprehended, if we follow that mantra, then it's going to be a failure, and that is something that we can't afford to. So I think that is the area that we need to very, very keenly focus upon. I'm not going to take up much more of your time and leave the house open to the esteemed panelists. So let's go through for a very engaging session, and we can start, I think, with Mr. Weber.
Thank you, General Johar, for the very nice talk on excitement and potential which you have given to the Indian industry. And we believe that we will live up to the Army's expectation. And I would like to now share my presentation on this talk. I hope my screen is visible to everybody.
Yes, it is.
Thank you, sir. So MKU is all about the heroes who are there at the border or in internal security forces who are guarding us and protecting us from the any kind of miseventualities that may happen. So my talk is on Night Vision India 2021 Emerging Technologies in Electro-optics, and we as MKU believe strongly in Atmanirbhar Bharat. And today, as we are speaking, we are also exporting our night vision devices to countries in Southeast Asia and South America like Brazil. To begin with, scene of Delhi. On the left-hand side is what it is today, as you can see, and what it gets into in the dark and what it happens in the daytime. And I think that this slide itself is a perfect example of why electro-optics are required, because there are different scenarios in a given environment where things can change dramatically, and you have to go for different kind of sensors to look around you and be situationally aware as to where you are and how your enemy is behaving in that environment. And then you need to make quick decisions, and this is where electro-optics, I think so, comes into play. So MKU is a company which has been there since last 3 decades. We have been recognized by Ministry of Science and Technology for our R&D efforts. We have patented technologies. We believe in large infrastructures, and we strongly are advocates of R&D and innovation. And we have been propelled by the export market to deliver high quality products, not only to exports but to India itself. And India is a market for us where we not only do R&D but also try to cut our costs, because it's driven by cost. So it's a very challenging market but very interesting market, and a lot of the foreign companies are also interested in participating in this arena. And today we are proud to say that MKU's products are being exported to 100 countries. 230 forces are using our products. Some of the international organizations of military kind we are associated with are listed on the VFOIL. It's NATO, UN, and SHAPE, and OSE. These are in Europe. Now I would like to cover phase by phase the different kind of technologies MKU is dealing in, starting with image intensification technologies. So principally, this is how a night vision works, and I think so a lot of the people might be aware, but still I'm just showing it here for the clarity of everybody, that photons enter through the photocathode, and then they get get converted into electrons. And there is a microchannel plate which multiplies these electrons into millions of times, and then the electrons further penetrate through the phosphor screen, and then they get converted to photons. And what we see is a green light or at the objective side, on the eyepiece side. So the advantages of this technology is that you can easily identify faces, you can read your maps. It helps you to be situationally aware about yourself in hostile territory, and it has the ability to look through glass and window panes. And also it helps you to do room intervention operations, and especially good for built up areas like in J&K and places where you are combing out in a small zone. So this is a very good technology in those environments. Suggestions for this technology moving forward is getting into the Gen 3 arena, offering resolution of 72 and a signal to noise ratio of 28, which gives a figure of merit, and Colonel Kuber spoke about this term. But figure of merit primarily is to identify the quality of the image your night vision is able to produce. And it is like today when we look at different kind of formats in TVs, so you have the old LCDs, then you have the LEDs, and now you have the QLEDs and the OLEDs. So everything is changing by time to give the user a very immersive experience, and the same experience we want to bring to our military friends that, with clear image, you can look through the dark very well and identify your targets very easily. Apart from that, we have auto gain control and brightness source protection inbuilt into the II tube. Apart from that, the auto gating is a new feature because it cuts the highlight conditions when you're operating in, and it reduces the blooming effect or the glare effect which is generated by bright lights. We have developed the indigenous night vision, which is resistant up to 5-meter water depth, also going up to 20-meter water depth for special forces. And we have reduced the size, weight, and power consumption. So all in all, it's a total package of performance and especially suited for smaller ranges for the carbines. Already there is a big program for night sight for carbines going on. And one of the vendors is our company who has participated in that program. And in that, Army is looking forward to these kinds of systems. So this is some of the night vision products which we have. Night vision monocular, we call it the NM3000. Then we have the night vision binocular. Then we have the night vision II weapon sight. And very necessary is to have a good mounting attachment system, because when the soldier is wanting to use his gear or the devices, he should not be obstructed by many things in his hands. So there is a system which MKU has developed internally in India, and we have applied for patent. It's called the multi-axillary connector system, which can be easily mounted to the helmet. Doesn't need any bolts to be mounted. It can be mounted even on the existing helmets which the Indian Army has, and it can be mounted as well on other suppliers' helmets as well. And this is a very advanced kind of connector system, and I can vouch for it. It is not available anywhere in the world today. We are doing it in India, and it is having all kinds of interfaces for mounting your night vision devices, for mounting your cameras, for mounting your torches, and very easy to use and highly recommended for soldiers on the ground because they have to carry a lot of equipment. Going forward, we are looking into the development of our own uncooled based IR detector as well as the camera. And right now, we heard DG Infantry that the Indian companies should focus on development of the own cameras because we are dependent right now on imports and foreign players. So this is where we bring in a lot of expertise. We have developed the cameras, and we are going to offer them for trials soon with our latest, thermal imaging sites for the MMGs and DI assault. And what we are also bringing further into this technology is the 12 micron pitch, which will reduce the size, the weight, and power consumption. And the camera will be operated by using field programmable gate arrays, which we call in computer terms FPGA. They are very fast and optimized for low power consumption. And the very nice thing about these is that they deliver near real-time imagery. So right now, whenever we see a sensor and the display, there is a lot of time which is spent by the algorithm in processing that image from the sensor and giving it to the display. And this is where our technology, which we are using here, the FPGA technology, reduces these lags, and you see real-time imagery, near real-time imagery at your display. And we are also developing new kinds of algorithms which will help in very smooth non-uniformity corrections which are required in the LWIR sensors. And these are must to have because earlier ones which were manual used to obstruct the user for a little bit of time when he was operating in critical environments, which was not a desirable situation. Going forward, we are looking at multi-sensor fusion. Our teams of technicians and engineers and PhDs are working very seriously on this, and we are trying to bring world-class fusion systems, which I will just share with you on the view file. So these are some of the technologies which we are developing. We are using a fused image between the II channel as well as the uncooled LWIR channel, along with information fusing as well. So it is really required that today you must be aware about your headings and your GPS locations. So all this will be built into these devices, and they will be offered here in India. No need of importing. And we would be ready very soon, and we would be displaying this we'll be offering this for demonstrations maybe by the end of this year or maybe next year. Now, when we talk about fusion, a lot of the people understand fusion as something which is not customizable. But here is our team of experts and software engineers who really did a marvelous job of customizing fusion. So you'll be able to control the channel feed. And the next slide I'll just show you. So if you look at these two videos, starting from the top, on the left hand side, you see there is a TI channel, and then there is a day camera channel in the middle, and then you are getting a fused image. But on the top, if you see, there is a fused image which is having 30% thermal content and 70% day CMOS content. And on the bottom, you are seeing 70% thermal content and 30% day CMOS content. And why I would wanted to show you this video, because when I started in the my presentation, I showed to you 3 photos of India Gate. So this is the kind of solution which we would require in the future, because just using one channel will not help anybody to look into the area of interest. You might want to on the go change your channels or switch between fusion modes. You want to go for higher thermal content, lower CMOS content, and vice versa, because at given point of time, the scenarios change, the lighting conditions are changing, there is fog or dark conditions. So this kind of arrangement, I think so, will really help the users on the ground or in the air. And this is what we are developing today at MKU, and very proud to say that our team of engineers are doing a fantastic job. But this is just a small video I got from them, and I'm showing it to you. Then we are going ahead with DRDO. We are getting the driver night sight technology from DRDO, can be used on AFVs and platforms. And the beauty of this product is that it can be vertically mounted as well as horizontally mounted. It can be used on AFVs. It can be used on other vehicles or civil vehicles as well. It uses a low light CMOS camera as well as a TI camera. So it helps the driver to drive in the night without switching on his own lights. And this is a very beautiful feature, because we can imagine CRPF vehicle driving in areas of Jharkhand or somewhere where it gets really risky. So without the need of switching on the light and just using this technology, the driver would be able to drive his vehicle perfectly in all the conditions. And we believe this is the technology for the future. Even in electric vehicles, such technologies are being worked upon. And this is something which Indian Army and the paramilitary forces can take advantage of. And it will be made in India, in MKU and other places where DRDO is giving their technology. And one of them is MKU. And we would like to thank DRDO for considering us for this technology. We feel really excited, and we believe a lot in this technology. And I think so it will be really good product for exports as well. A lot of the speakers mentioned about multi-spectral cameras. Yes, we also believe in this. And like my fusion slides showed to you, that one sensor may not answer everything. So we have here NIR, SWIR, MWIR, LWIR, all coming together in one pack. And every sensor has its own limitations. The day sensor works in a particular band, the night sensors work in particular band. But going forward, maybe the SWIR may do a lot of the job, but still, you might need other sensors as well. But SWIR offers a lot of advantages. It offers you good image contrast, and the images are comparable to visible images, and it can see through fog, which LWR, MWIR have a disadvantage, or have lesser capability in, and it can look through glass, which LWIR and MWIR missed to do. So we believe that this technology also will be helpful, and not only this technology, but combined with other technologies. We are not only building it for military operations, but other operations as well, for civilian use and other platform use, which may be good for everybody who are wanting to, look through the dark environment. This is an example of what each sensor image would look like. So on the left hand side is a black and white visible camera. Then you have the SWIR, and you can see the visible and the SWIR are more or less on the same lines, whereas the MWIR and LWIR are not offering any kind of recognition capabilities. And this is the beauty of the SWIR camera, that a lot of things comes into one. And right now it is a little bit expensive detector, but I think so moving into the future, this sensor should get economically, cost should reduce because of the economies of scale. And this is where the world is also moving to. And I think so the other speakers from foreign countries will also touch upon this point. Then there is one more slide which shows to you the advantages of the SWIR camera in the middle. As you can see, the left-hand side is a visible camera, and this has been done using an artificial fog in a given territory. And on the left-hand side, when the fog is getting denser, the SWIR is still able to see. And the problem with LWIR, though it is able to penetrate the fog, but there is no recognition advantage. So this is again a challenge. So this is where SWIR comes in handy. We are, as I told you, very much inclined to R&D and design and development. Some of the tools which we are using are SolidWorks for our opto-mechanical design capabilities. Then we are using ZMax Studio for designing our optics, which is one of the world-class softwares in the industry. Then we have used electronics, which are ARM-based processors and FPGAs, and getting faster processing done on these semiconductors. This is another FPGA from Xilinx, which we are using in our design and development. And this, I think so every company here present might be using, because this is one of the greatest softwares for simulations called MATLAB, and we are using it to design our deep learning, machine learning algorithms, which I think so in the next Night Vision India seminar, we would be able to share some of the deep learning and the machine learning algorithms which we will be deploying on our sensor platforms, and how the user will be able to take advantage. And this is happening right now and right here. So not too much into the future. And we believe by next, or maybe next 1 or 2 years, we should see some of the products having this kind of capability. We have invested a lot of money into doing good quality testing and inspection, and we have our own manufacturing setup in Kanpur, and we have invested a lot of money in developing a world-class lab, because military products demand ruggedness and durability, and all this is being checked before we are shipping in India or exporting to the world, like I told you, to Brazil or to Southeast Asia and Philippines. And these are Generation 3 night vision devices which are being procured. And like Colonel Kober pointed out, that we should look at technologies which are already being built in India, and if they are being able to export to the world, then why Indian Army cannot, harness these technologies for their own selves? And it would be a pity that, things are getting exported to the world and our forces are not being able to use such technologies. So we strongly recommend DG Infantry to look at these technologies which are available in the country, in the private sector or in the DPSU. Some of the other test stations which we have our own image intensifier tube test stations and night vision test stations, and this help us really to have a very strong supply chain, because whenever we are getting our sensors from outside India, it's very important to check them and to check their quality, because merely relying on the data sheets being sent by foreign players is, I think so, not the correct way of procuring your sensors or detectors. So this is where we have invested, and we really feel proud that these are one of the latest test equipments in the country. And we most humbly invite Indian Army and other forces to visit us and see our facilities and take advantage of any kind of development or any kind of educational survey you would like to do. We would be most happy to assist your officers and your staff to do so. That's about us, sir. Thank you so much for giving me this opportunity.
Okay, thank you, Vaibhav. Very, very interesting to hear the kind of work that you are doing at your in your industry. And I think the fact that you're exporting to over 100 as also the Indian entities, I think you're a true epitome of Atmanirbhar Bharat, no doubt about it. So our compliments to you. And an amazing range of products that you showcased here. Multi-sensor fusion technology. We talked about it when you visited my office. And the driver night sight that you're working with the DRDO on. Right now, we are switching between TI and II to get the depth, but I'm quite sure the next step, which DRDO is going to tell you, is no switching. Let's fuse it so that the driver doesn't need to work on that. And of course, multi-spectral camera. This is something that we have been also looking at very, very critically for obvious reasons. The capability enhancement that it gives to our ISR resources also to be able to see through various conditions which other optical devices are not able to look through. So I think, yes, this is great. And then to marry it with the AI and machine learning, wow, that's the future. So great, thank you so much. And now I'll request Dr. Ranjana to kindly deliver her talk on survey of night vision and electro-optical developments worldwide. And I think coming from an expert like her, we are going to be deeply influenced in the Army Design Bureau and start looking at the technologies that she tells us today. So all yours, ma'am.
Are you able to see? Okay.
Yes, madam,
yes.
I can see, I can hear you.
Okay. No, the presentation is visible?
Yes, it is.
Okay. So I'll just quickly go through. Actually, Vaibhav has made my life very simpler because he's working on the cutting edge technologies. So we have this particular future directions that we thought. So let us look at the application starting before we go to the future directions. The ISR is a very well-known application vector for the night vision devices and the thermal imaging, as well as the EOIR. The targeting and tracking systems on board the missiles, they require the EOIR sensors. The guidance systems require some EOIR sensors. And basically, they have to control the movement of the missile and weapon, and that is why a deep integration of the missiles and the system which they are integrated with is required. Then you have to use the position velocity acceleration married to an EOIR sensor to follow the trajectory that you intend to take. And the guidance systems can be man in the loop or fully autonomous or semi-autonomous. Then homing head systems is another application vector of these EOIR systems, which require the sensor image as the source and the target position. Now, system on the missile is basically what is required to follow this kind of a positioning and guiding using the actuators. Now, this particular feedback, the homing, is given to the actuator, and EOIR is one of the sensors. So this is apart from what we are talking about, the ground-based applications. Definitely in terms of drones and other things, this homing head systems and guidance systems and targeting and tracking systems become very, very important. Now, what do we want in terms of the electro-optic sensors is detection, recognition, identification, positioning, and finally tracking with the help of all these activities. Now, if you see the challenges, I think it's very well known. The people in the field out there know that the challenges are the environmental disturbances through fog, dust, rain, evaporation, heat turbulence, and solar radiation, clouds. Everything possible on in the environment is a deterrence to this particular technology. And when you say this, your EOIR designs have to overcome all these deterrences, and that is what the design of this particular EOIR sensor requires. The design needs to address all these issues. And also, if you think about it, these are also the very easy technologies to actually camouflage yourself. So if you want to camouflage yourself, then a fog creator is a very matter of a very simple technology today. So the dust smoke covers cloaks. Basically, they cause the absorption and there is a transmission loss. So your sensor has to overcome this. Coatings and the cover application. So if you have a cloak, something like that, you have the scene contrast change, and one has to, the EOIR sensor has to overcome this. Then natural fogs, rains, artificial smoke. So it actually changes the entire radiance of the scenario, and your sensors need to counter that. Then also producing and deploying mock-ups. So launching IR decoys is a matter of very easy technology today. So your signature change has to be identified. Now, if you see, we will, I think Vaibhav, and I think earlier also it is covered that what are the kind of sensors that we have. We have the night vision devices and we have thermal imaging, and they span the entire range of UV visible, near IR, SWIR, MWIR and LWIR, and of course multicolor, going from single color to multicolor. Now, where do we, how do we, address all these entire spectrum of the visibility that we want to ensure and overcoming the deterrences? So if you see, this is the physics behind it, that what gets affected by the coatings, cloaking, clatters, mock-ups, and the obscurants. Now, not going too much into the detail, the idea is that the basic physics process, these need to be overcome. And at DRDO, we are working primarily to overcome these kind of difficulties and enable the sensors and the technologies to overcome that. Definitely the sensor work was a little slow, but it has picked up very effectively, and we are working very closely with the academia very, very seriously, especially with IIT Delhi, to overcome some of these kind of challenges, and not only to overcome these challenges, also to do the in-house manufacturing of sensors which are majorly being imported. Now, improving the capability of an EOIR sensor, we know it's night vision devices which are infrared, also the infrared illuminated, laser illuminated, then thermal images are in the 4 ranges, then multiple sensors. Now, if you have this kind of sensors, already he showed a very good example of merging the thermal image as well as the visible images, but definitely all kind of sites, all kind of sensors can be used to actually integrate and bring out the better sight or better outcome of a particular sensor. Multi-spectral sensors, image processing. Now, the major portion that comes out of having the multiple sensor is that you have to have very deep image processing, signal processing. Now, both are required in tandem to bring out the best outcomes from the sensors. And after you get out of all these problems and you get to the processing, the calibration with respect to the scenarios is one of the very important factors which actually technology is driving into. So after using all these sensors, you fuse the signals, you fuse the image, and then do the calibration to get the best performance. Now, once you have the best performance in terms of sensors by integrating multiple types of sensors, you also need to improve the utility in the system, and that is by laser rangefinders, laser targeting, deep integration with homing, the stabilization on board the moving systems, and also in one more thing is the your fast frame rate for the images, then edge computing. So if you have all the computing on the particular device possible, but it is a lot of money and also a lot of weight to the system. Instead, going for the cloud processing in the limited areas, again the design is required around it. Then data fusion from multiple sources, AI ML for the target identification as well as target classification, a very important aspect for these kind of sensors, and integrated scenario management of sensors. Now, this is the next level, wherever the battle management itself is talking to, say, hundreds of sensors, and if one sensor is not able to identify, you take the cue from the other sensor and start, marrying it with the sensor which has lesser visibility and getting the best out of these particular systems, and also overcoming the EOIR countermeasures. Now, improvement directions, the future directions of the technology moves in terms of sensors. We talked about it, and a lot is being done with the help of academia within the country. The latest is the conformal arrays and the curved FPAs, which are coming in instead of the flat panel arrays, which we call as FPAs. We are getting a slightly curved FPAs, which are very natural, and they are inspired from the bio sensors. Then in terms of materials, a lot of work for the sensors is happening in terms of semiconductors for CMOS, coatings in terms of a lot of types of coatings, processes, the slight change in processes, tuning of processes improves the sensors. And finally, the characterization of each sensor is a very time-consuming process to bring out the best out of the sensor. So even if you apply a particular type of coating using a particular type of process, how does it impact the final performance is something which is a very deep research oriented work. Then the types of algorithms, a lot of things are available in the open, but many of them are also in a very confidential space. The best algorithms to get the best out of all these image processing is something that we need to really work a lot. And I'm sure this, along with DRDO, a lot of startups are also coming in the space of AI and ML. Computation requires optimization of computation because we don't have the unending computation in the field scenarios. Then deep integration of sensors, data, information, everything together with man in the loop or total autonomous. High-speed imagery is something which is very important. So to have a very realistic targeting. So even if you are able to see the imagery, if you are not able to act on it, or you're not able to target using that, it will be very difficult. So your image refresh rates are very important to work upon. Cost is a factor, I think we all know, and with this pandemic, we have to optimize our cost at every level. So optimizing the cost in the research level, in the manufacturing level, and at the deployment level, all need to be optimized. They have to have all weather, day, night, the range. So I was just going through, I think the future speakers who will be talking, they are talking about a lot of sensors which have a very long range. In fact, up to the 8 kilometer of the range, they have the identification of the humans in certain scenarios. Now, for every kind of a process or a coating or a semiconductor or the sensors, you have to characterize with respect to the range. And then we already talked about overcoming countermeasures, and these need to improve continuously because this kind of cameras have very easy obscurance coming into the field of play very easily. So there is a requirement of multiple sensors fusing together to come to overcome these countermeasures. So I think night vision devices, we all know from 60s how they have grown up to 2000s. And academically speaking, there is Gen 4 is yet to be declared, and Gen 3++ is basically having auto gating, which MKU presented. And there is a very good decreased thickness of the ion barriers. Now with all these technologies, what you are continuously improving is the image quality and the reliability of what we are seeing, then reduction of the size of the device and reduced SNR. This is the overall aim, including the cost. Now, what we are also looking at with these night vision devices, what have been the related technologies have been filters, image intensifier tubes, high-end optics, the digital technologies. NVDs also come in two flavors, the analog ones and the digital ones. Now, digital technologies have also matured quite a lot. Earlier, there was an apprehension that digital technologies are not at par with the analog ones. But slowly, with the time, we are improving on it. Then improved field of use are coming in very fast, definitely married with signal and image processing. And the displays, also today we have OLEDs and QLEDs to help us with the displays. And also this supports the high-speed imageries. Then conventional, I think all technologies are important for both conventional as well as digital NVDs. Thermal imaging, again, you have the NIR, then SWIR, MWIR, LWIR. What is coming in is the technologies which are for the uncooled detectors, it's bolometers. A lot of work is already being done and it's quite a mature, but there is no end to improvement. These are being worked on. The detectors, which are the cool detectors, the cooling technologies have been improving. And today we started with the nitrogen coolers, but today Stirling coolers are being used, but they have a little problem with the life. And currently the available best in class is 8,000 hours of life with the Stirling coolers. So definitely this is going to be improved. And for these kind of thermal imagers, there is a multi-step calibration which needs to be done before the use. And this is a very important factor for the field usage. So this needs to be optimized for quick usage in the field. And in terms of detector types, if you see the mercury, cadmium, tellurium, they are being used very extensively for both the shortwave as well as the long wave. And the major thing today coming up is the quantum dot technology, which is very recent, and definitely they are going to be very useful. It's very promising technology, but how it gets deployed in the actual sensors within the country, definitely outside they have already come up with. And the new cameras, especially the cameras which are on board our microphones and our mobiles, they are very, very advanced, and they are able to see image identification during the night also, and visible light also. So this is some technology which has to be really worked as the quantum dot technology, which needs to be taken up very fast. Now, if you see the maturity level of bolometer is TRL 9, almost in the production. Then for all this mercury, cadmium, tellurium, it's TRL 9. Quantum WIP is in TRL 9, but quantum dot is I think at TRL 6, which can be really commercialized very soon. In coming 1 or 2 years, we'll see large changes. Similarly, for the other technologies which are still in the research and development, basically your T2SLs and the indium-based, indium arsenic, and I think this SB-based, antimony-based systems. So they all have military applications and their limitations. So always, again, multi-spectral and multi-sensor fusion is the requirement. So I talked about the quantum dot nanotechnology is emerging, panoramic vision in the NVDs, and high sensitivity CMOS technology for NVDs is something which is really emerging and will be very useful for the system. Again, the FPA technology is again for higher resolution digital pixels and pixel level signal processing. They are being used very effectively. But the only thing is these technologies also are being married very, very fast with AI, machine deep learning, and for the better target detection, recognition, identification, and tracking. And for laser applications also, active imaging is being used, and these are going to be in the field very soon. Okay, the laser rangefinders was not really very directly there. They are more required for the homing. And so I skipped that particular slide rather than filling it up. But definitely they also have to be looked when you are going to deploy it for the moving systems, like, laser trackers and other things. So with this, I think this is what directions today we have in terms of NVDs. And I think tomorrow our IRD team is going to cover extensively what they are developing in-house using the existing technologies and the technologies they are working. In terms of academia, a lot of work is going on for improving the processes as well as the materials. So this is where we are. Thank you so much.
Thank you so much, ma'am. Dr. Rajnath, you've been able to give us a complete overview of the latest technologies and the future of night vision and electro-optical developments. I think there's tremendous amount of learning that we got here today, and enhancing visibility, systems, improvement, directions, really showcases the kind of work that is being done by as also the fusion that is being brought about between you and the industry, as also the academia. So I think we are going to see a lot of developments in this field. Thank you so much. Your parting thing of optimizing costs, I think that's very important for us. It needs to be looked at also while investing in these technologies, of course. So thank you so much for your insights, and really look forward to interacting more with you to see as to how we can take this forward. Now we have, I think, the speaker from HGS, Mr. Dixit, is online. So I think I hand over the floor to you, sir.
Thank you, Major General KV Johar, IMR Media. So I'll just start with my presentation. Are you able to see the presentation?
Yes, we are.
So I will just quickly brief you about HGH first. HGH is a French company which has been started in 1982, about 38 years old. Primarily experts in the field of electro-optics. Started by two pioneering innovators in the field of infrared technology, Reconnaissance and Gilbert Gasagau. Mr. Gasagau has also written a book on infrared thermography, which has been widely used by many people globally. As a company, there are 100 plus employees. We have two R&D centers, one in France, where the headquarters is, and the other in the US. Today, systems are installed in over 100 countries over these years. There are primarily three areas of segments where HGH focuses on. So we have on defense and security and surveillance, we have a 360-degree panoramic IRST surveillance system. We have products which are for test and metrology, where we manufacture an extensive range of like black bodies to collimeters to test benches, and something for the industrial application, where we have a non-contact temperature monitoring applications, primarily used in the cement and power sectors. So these are the three broad categories. IR panoramic surveillance. Primarily, HGH manufactures only the panoramic cameras, not the fixed or the PTZ or the binoculars. We have a test and measurement and the industrial thermography. Today, I'm covering primarily the test and measurement products with relevant to the night vision capabilities, as has been in the segment so far. HGH has a wide range of black bodies, which range from low temperature applications to high temperature and even up to vacuum, an extensive range of black bodies. Integrating spheres, primarily used for testing visible and near IR applications. Night vision tests, primarily for night vision goggles, monoculars, binoculars, and multi-spectral products. Then we have fully automated electro-optic test benches for detector level applications. We have collimeters for testing infrared for cameras, LRF also, and we have software, universal software, which helps you and the user to assist them in various tests for MRTD, NETD, MTF, a whole lot of tests through this software. Briefly, yeah, some of the prominent customers globally, which AGH has, you can see also specifically some prominent camera manufacturers, military test stations. In India, of course, even with premier institutes with DRDO and ISRO, are also using some of AGH test and measurement products today. So coming to the military test benches, specifically for the night vision goggles testing, one of the most relevant parts for a user is that it is ITAR free. There are no export restrictions for these products. So this is the first and the immediate question which normally comes to us. So one, that this is ITAR free, it is following a lot of global standards. There are 3 products here. Primarily, we have the NV 2020, which is primarily at the user level, at the field level, where you want to test just before going in for any ops. So the soldier can immediately test whether his monoculars, binoculars are okay, and then proceed. This is to be tested in a dark room. The second product is the NV 2500M, which is for a complete maintenance of the night vision goggle testing. So many times with a period of time of usage, when you want to test that there are issues which you are facing on the goggles, so this could be a system which helps you to run a few quick tests to know whether there are issues in the NVDs which you're using. And the third is a Opal bench, which is a very elaborate, comprehensive, and yet a modular way of approaching, where you can test night vision goggles, binoculars, multi-spectrals. We can use test the multi-spectral at the same time. It's an extensive suite of tests which you can run here, typically for manufacturers or which they can use. If we look at NV 2020, so this is a product which is to be used just before field. Advantage here that you can test at a quarter moon level or a starlight level. It is a portable system. It is battery powered, and you can comfortably use it or fix it on a wall, or you can carry it to a mobile unit. So it gives a lot of flexibility for a user, and it is very easy to use. So the buttons are given on top. I will just take you to the next slide. Yeah. So just taking off the top cover, this is where you get to see it. So buttons are given here where you can switch it on, easy for the user. And if there's a low battery indicator here, plus in case when you're using it, so you just got to wait for the status of the lights, and you got to use this system. Now this needs to be used in a dark room. That is the only requirement. Otherwise, it's a fairly easy system to just set it up and use it. What you get to see when you test it, I've just put something on the right here, so it's easier. Maybe, for example, when you see it, it's a small clip, but when I magnify it, I've taken a screenshot of what you get to see. So there are different numbers of resolution targets which are given here, and depending what you see, so you will get to know whether you're having any issues with the goggles that you're using. Fairly easily used, today used by many globally military customers. The second product is the NV2500. Now, this is a system where it will help to assess all kinds of tests which you can run quickly. You can have a number of tests which are related to its resolution, gain, spot defects, MTFs. So all these for you to run without having to go back to the manufacturer, because now we are in a situation where already there are a set of older generation, maybe goggles which are being used. There are multiple manufacturers now quoting in, the requirements are going more. So there are different types of night vision goggles which will be in use. And to test it, to contact every manufacturer every time, is one part of an issue for maybe for the user and the buyer. So this could be a system which could be used by the user, for example, by the Indian Army, maybe at certain command level, or they can identify certain levels where they can collect the defective ones and test it before sending out to the manufacturer that these are the goggles. The same way, this could be used by the manufacturer before they supply to the end user. So this system can be used by both. And this is an advantage, and it can become a seamless way of operation between the buyer and the user. For the buyer, it becomes more holistic because there are multiple manufacturers you are working with. All you will need is a different set of adapter, which we will supply depending on which manufacturer it is. And already we have a lot of adapters which have been manufactured globally for various night vision device manufacturers. So we could very easily use the same one or modify one or supply another one as required. And here, this whole system, it's a complete unit where the display is fixed and it is a self-assisted, it is fully automated. You just have to select what you want to do. Automatically, it runs the test for the user. So it is very, very easy for them to use it. Now, if you look at the kind of standard tests which are there, of course, at the resolution, gain, or spot defects, the zero diopter is a very interesting one where primarily we would be testing the ring of the eyepiece of the binocular which is there. So this way it becomes a wholesome set of tests, because those are also areas which could have issues when you bring out for defects in terms of NVDs after usage. So we have the next one is the Opal bench. So this there are various options which manufacturer can look at to use. So this is one is for just testing basic night vision goggles. Second could be for the thermal cameras, and third are for the weapon sights and for the multispectral cameras and NVDs that we are using. So the Opal bench is something which will help and a manufacturer definitely. One, maybe to go from a scale up in a modular way becomes much easier for them. So now if you look at the kind of tests that which can run on the Opal bench, so right from the, these are the standard sets of tests quite extensively covered, right from the NETD, the SITF, spot defect, gain. There are extensive range of tests which are available here. These are installed on a with a software on the PC, and you can run all of these tests. So you could even look at testing the bore sighting, which is there, okay, which will be relevant, especially when we look at multispectral kind of applications. Now, these sets of tests, depending on which product you choose or which configuration that you choose, you can have all these tests to run on. So primarily when we look at the present situation from the manufacturer's point of view, whether we want to look at the NVG, which is just for a set of tests, or do we look at the NV2500 or do we look at the Opal bench? So these are maybe some points which we put across because it is easy to use depending on what stage. Because today there are manufacturers in various stages. Some who have just started manufacturing, some who have done 1 line, 2 lines of production now, and there are some who have been there for quite a lot of time, and some who are progressing into advanced stages. Like the image which you can see in the rightmost, now that is for a sniper. That is why you see that it is fairly long. You can look at this. It is a very long spacing here, and this is as per what is supplied, and this could also be used for testing. So depending on the status, but the advantage is again that AGH carries a tremendous know-how within the company with all of these products. It's been there for decades now, and in the field, experts in this field. All these products are designed, developed, and manufactured by AGH, which is one of the most important criteria. There is no outsourcing or contract manufacturing which has been done. So there's a tremendous level of quality control and performance which is achieved. There's a high level of accuracy of the tests which are maintained, because there's a complete control in the entire test setup that has been supplied. So apart from these, also are at the detector level, full-fledged test benches that we supply. So these are the various options which are there for night vision goggle testing, especially when we see now manufacturers going for even up to automated gated kind of systems, because that is the biggest challenge when it comes to using NVDs. But we are able to test even for those kind of goggles. Okay. Should you have any questions, any feedback, do contact us maybe after this show, or you could connect with us with our email IDs and mobile numbers. They're given here. Thank you for the time. Thank you for a patient listening. Good day.
Thank you, Ambarish. I think that was a very, very informative talk that you just delivered. Maintenance in field has been a problem, especially for the military, because with the developing technology and the maintenance requirements, they become more critical. And obviously, such extreme technology devices, they generally require sterile environments and dark rooms, which are not available in the field where we operate. So obviously, testing systems can give us that advantage if we can take them to the field and test the device in the field. So thank you very much for giving us a scan of your solutions that you have on offer. And now I think we have Mr. Ronan online from Semiconductor Devices, if I'm not wrong.
Yes, morning.
Yes, so Mr. Ronan, I think let me just introduce you. You've been part of the semiconductor industry in various global positions, and you have been working with local partners in India, governmental, commercial, and homeland, bringing SCD's innovative solutions to the Indian market. So I think we'll be very, very interested in listening to what is the latest work that you guys are doing and what is available in the world market that we can really tap into. So the field is yours.
Good morning or good afternoon, everybody. First, I would like to say greetings from Israel. I'm sitting now at home, not as close as possible to India, but this is an excellent occasion for me to say Happy New Year to everybody, to my colleagues, to my friends in India, to you, Chair, and a healthy year to all of us. So again, good afternoon to whoever is India, good morning to Israel here. First, I would like to say who is SCD in numbers. We are going to talk about SCD and its innovation technology. First, a second here, because the security is blocking me. Okay. So a little bit about SCD. SCD is a world-class innovative technology company for IR detector and laser diode detector. We are located, of course, in Israel as the headquarters. We have an office in the UK and companies in US. We have what we call SCD USA, together with our subsidiary Quantum Imaging, and we have a liaison office in India. As you can see, we have a dedicated person and significant importance for India as a continent, as a country, and customer. Israel SCD has 33,000 square feet of clean rooms. And our last year turnover was raised again successfully, a very successful year for 2019, over 180 million US dollars. And I can share with you or tell you that even if in the Corona period we were able to top and overreach these numbers for 2020, even with the Corona period. Our significant R&D activities and infrastructure is located in Israel. We have hundreds of doctors and PhDs and specialists in IR technology and, of course, the production and so on. Our experience is over 40 years of proven operational and technology leadership in the world. And currently we are more than 600 employees in various locations, but most of them are located in Israel. What we can say about SCD technology and capabilities. First, we have IR imaging system performance analysis. We have all the technology and capabilities. Semiconductor devices simulation and designs that was developed dedicated for this market for the last 40 years. We have our own material growth. So we, from the level of the crystallization and growth in LEE and NVE technology, microelectronics processing of semiconductor devices, our own mixed VLSI design for ROIC, we do it in-house, flip chip bonding for FPA, nanotechnology, packaging of IR detectors, design, integration, hardware, firmware, and of course, real-time imaging processes for IR video engines. All this is our own capabilities and technology that was developed and reached to a very fine level of capabilities for the last 40 years. You can see here down a little bit of our wonderful team in the fabrication area with the variety of different wafers. As some of my colleagues here and the other lecture already discussed, as a world leader manufacturer of infrared imaging, we have abilities and technology to master and provide solutions throughout the infrared spectrum, from the V's to the long wave IR, from the reflector to the emission part of it. And this is the advantage, or one of the advantages, that it's a one-stop shop that you can find the right solution for the right application, whichever it is. I would like to share with you what are, I would like to share with you what are the key trends in the IR detectors development that are now emerging and looking into the future for today and for tomorrow. One is increased spatial resolution. It means a large area and a smaller pixel. We are looking at very aggressive trends in decreasing the pixel size from one side, and on the other hand, we look at the large areas. If we used to discuss in the past about a quarter VGA, we are now talking about 3 megapixel and even more large areas and small pixels, down from 30 to 25 to 10 micron and even below in the future. We are looking at the reduction in size, weight, and power, which enables our customers to deploy more and more systems into their application in a widespread distribution, and enables more and more channels in one payload, for example. 3, we understand and work on a regular basis to lower cost. We understand that one of the driven keys and elements is, of course, lower cost, and we work and do our best. And this is what we can see, how we increased some of our markets throughout the world. The 4th trend that we can see is spectral coverage and dual band. We're talking more and more on dual bands, and that mid-wave, long wave, and other, or short wave, long wave, and a combination of the two in variety of technologies. The 5th one is higher performance. Everybody's talking about the lifetime of the detector, increasing the lifetime of the cooler, the sensitivity, the frame rate, image quality, and of course, handling a variety of environmental conditions. If it is a fog area, if it's a cold area, if it's a rainy area, if it's a very harsh area, if it's humidity, if it's a coastal area, and so on. And together, integrating functionality is a system, size, weight, and power, and cost together. All these goodies that we can provide to our customer is basically on our wafer to detector process that we have mastered for the last 40 years in our production facility, through fine-tuning each one of the production stages in order to develop the best technology, the best detector that exists today in the market, from the photolithography, etching, dicing, through the final test and readiness for delivery. And all this done in our unique and state-of-the-art production line that I would like to share with you a little bit in a short video coming next. Can you hear it?
Yes, I can see.
Can you hear it also?
Wait. Yes, but can't make out what is he saying. We can read it, but cannot hear it.
You cannot hear it. Oh, you heard that?
No, we could only read. We could not hear in that video.
Oh, I apologize for that because
You
of
can
the.
send. You Ronan. You can send the video to me. We will play it during the breaks.
Okay, sir. Thank you. I just here through the video of the IR detector, I have share with you a little bit about our continuous of investment in our production line, and this is a real need for us in order to meet today's challenges and the future challenges that we see and face in the market. The significant growth of SED for the last couple of years, I would say 5 to 6 years, we have more than doubled our production, our sales, and the technology was significantly invested in that. So in order to be prepared, one side to the demands from the market and to the future production and technology roadmap, we meet and increase and develop on continuous basis our fabrication and technology from one side and on R&D investments on the other hand. Next to the detector itself, we also take in very serious manner the capabilities, and we understand the needs that it's come from the market for the video engine for the detectors. Customers are not only focusing on the detector and would like to us provide also video engine in the IR detectors. And as we meet the challenge and continue to develop it from vanadium oxide imager uncooled detector is a techless and a 640 by 480 17 micron, together with our own state-of-the-art video engine, a shortwave IR imager based on gallium arsenide at 645 15 micron FPA processing technology, and a cooled detector, mini Blackbird XPN, and HD detector with the K580 cooler. The last but not least is the Spiral, which is an XPN 640 512 10 micron. I would like to share with you a little bit and a short video on a shortwave imager video engine. You can see here an example of the state-of-the-art driving vision enhancement technology that was developed and being used and deployed already in the market on our shortwave IR imager, which is a core element of a core video that was developed in SCD. We were able to challenge and even increase the technology based on Gen 3 image intensifier that today in the market. It helps and supports situations like fog, smoke, and haze penetration in daytime.
Yeah.
Night vision goggles that are now using Gen 3 image intensifier, we have introduced the SWIR imager, a core technology and video engine that was developed in SCD and was successfully deployed in several of those conditions in moonless nights. You can see here an example of side-by-side of a test field that was done. You can see on the right side the Gen 3 image intensifier field, and on the left side the SWIR imager capabilities. I would like also to introduce our latest technology of the SPARROW detector, which is the state-of-the-art, the smallest one today in the VGA format, 10 micron pitch FPGA processing with the K590 cooler, which is a linear cooler and a linear technology that enables a longer MTBF and increased in its performance, and the small size, weight, and power that I just discussed earlier, it's exactly coming into reality in this detector. And of course, we also thought about the cost of it, which is a very attractive one, and aggressively we're pursuing toward that direction. The SPARROW is high performance, smaller size, very fit to drones applications and other applications that you will slowly see, like remote control weapon station and other. We have developed a miniature, small size, weight, and power detector for a miniature payloads or either binocular or handheld application for lightweight drones or UAVs. Swap less than 300 grams with a very attractive linear cooler. It's a hot XBN 64512 with an MTBF higher than 18,000 hours, which is extremely and excellent and challenging today. It's been deployed and been proven in security and surveillance applications. we have done the videos here for a wide range of applications. You can see at the bottom the ranges and the targeting that we were testing and evaluating through our development stage. It's an excellent performance in the night detection and recognition for human targets. You can see the excellent resolution and the DRI that was achieved. So in summary, the Sparrow is one additional video engine that we were able to develop and provide through our successful investment in video engine technology, meeting the customers' requirements and demand for video engine. Regarding the shortwave IR, the indium gallium arsenide, also my colleagues and my friends in other companies also has mentioned it. SED is the leader in the world for the shortwave IR. Our detectors, video engines, and cores are being deployed throughout the world, and we have started it long ago. I think more than 10 years ago, we invested significantly in the technology and the capabilities. And we started with the Cardinal 640, ceramic techless 15 micron pitch. In 2016 was deployed already, and we continue throughout the time with the Cardinal 320 to 256 30 micron. 2018 with two versions of one with a low noise and a ceramic and a PCB technology, and we recently shared and provided a large quantity of 1280 by 1024 10 micron Cardinal 1280, which is an HD state-of-the-art technology to a variety of applications throughout the world. And in this, I would like to end my presentation and thank you to all of you for giving me the time and the opportunity again to participate in night vision in India, and appreciate your time and your questions if you would like later on. Thank you so much for your time.
Thank you, Ronan. Thank you for giving us an overview of the available technologies. It was, I think, very interesting to see the video engines that your firm has developed, the SWIR imager, the Sparrow detector, high performance TI. Very interesting to see these latest technologies. And I'm sure the Indian industry, which is listening and would be definitely proud that they're right up there with the development that they are investing in, but also take a leap from the kind of technology that you have talked about. So thank you very much for your time. And I'm also told that we have Mr. Vinod Yadav from Tata Advanced Systems. I hope I got the company name right, because there's so many changes, it's difficult to keep track of them right now. He's, I think, head design, computing and optronics platforms, and he will be talking to us on technologies and solutions in the electro-optical domain. So I think I'll hand over the floor to you, sir.
Thank you, sir. And it's nearing lunchtime, so without wasting too much of time, I will just jump on to the relevant presentation of mine. And my colleague in the morning would have already given an overview. Just a moment. So already given an overview of the company. Just to reiterate, we used to be Tata Power SED earlier, And we are now Tata Advanced Systems Limited. It is part of the group's consolidation of all the defense business into one entity called Tata Advanced Systems Limited. And we are part of the weapon system and C4I systems group, weapon sensors and C4I. And I look after the optronics related design activities of within this team. So as brought out by my colleague, Mr. Ved Prakash in the morning, we have been developing night vision systems, electro-optic multi-sensor systems for the past 7 to 8 years now. And we have the complete end-to-end design as well as manufacturing, high volume manufacturing capability to manufacture these devices. We have a very strong R&D team, which is on continuous development of these products and systems. And we work very closely with the users to understand their needs and develop products in line with their requirements, while also trying to bring in the best of technologies that are available around the world in terms of sensors. Sensor onwards, everything is something that we do. Right. So some of the recent products that we have developed are the 50-kilometer long-range observation system. And we are proud to say that in a recent trials that were conducted, our system could do a vehicle detection at 50 kilometers, a long range, both for visible as well as thermal imaging. Besides this, we have been working on the uncooled thermal imaging. It is heartening to see that after years of pursuing this area, the tenders are coming in and they're coming in good numbers. And we are confident that our products and the previous generations that we have built, based on that, we'll be able to give, and based on the futuristic technology, we'll be able to give what the user wants. And for almost all types of sites, MMG, assault, LMG, we have products available. You can see the site for MMG that we have developed, and similarly, there are sites for assault rifle, LMG. We have a clip-on sight now, sights which can be placed in front of the day sight so that the bore sighting of the day sight is not disturbed. So this is also ready. Then we have recently developed the uncooled multifunction camera based on user requirement, which has day, uncooled thermal imaging, LRF all embedded into one uncooled device. We have recently delivered to the Navy Special Forces some 180 numbers of helmet-mounted night sights. These are third-gen figure of merit 1800 plus tubes with twin tubes that go into the device, giving a true binocular capability through twin channel. Besides this, we are delivering handheld monocular with LRF for Northern Command. And we have also developed a standalone shortwave infrared camera. Coming to the trends in the military EO domain, and something that we are also pursuing, we are seeing, of course, this goes without saying that SWIR reduction happens with every generation, and we also continually work towards that. Apart from that, we are looking at adoption of high definition sensors which are smaller in pixel pitch, giving them the ability to manufacture it in larger formats so that the user gets a high definition imagery. Besides this, we are working in, as the earlier speakers brought out, we are working in spectral bands such as SWIR and developing multi-sensor solutions around it. We are also working on improving the existing sensors capability by means of signal processing, both at the hardware and the software levels. We are doing the multi-spectral sensor fusion. We are adopting the higher FOM tubes. This is what we are promoting now, a higher FOM tube greater than 1800 for image intensification based night vision systems. Command and control for imaging sensors. Command and control is the necessary backbone. It's a multiplier because you can get more intelligence from different bits of information coming together, and you can fuse it together to get a more derived intelligence of the overall situation. So based on that, we have been working on command and control as well. Apart from that, multi-sensor data fusion, where we fuse a variety of censored information into one and give a common operating picture to the user. And as the world is moving towards in the non-defense areas as well, making use of the AI and ML processing techniques, we are looking at increasing the autonomy of the military sensors that we are providing by incorporating AI ML techniques at the edge, so that you get the required classification of targets on the edge device itself without any connectivity to the backend. Of course, the practical issues of power also persist, and we supplement these systems as part of an overall package by providing systems which give power autonomy for 24/7 operation. I'll take you through some of these trends, some of the examples, some of the videos that I'll show you which are taken from our device itself in the Indian environment. Here you can see multispectral sensor. This is an imaging, so not just in defense, this is kind of a good non-defense area also that you can see, where the day, the shortwave, and the thermal imaging have been showcased of how every sensor, if you see the day, it's not seeing anything. You see a shortwave infrared, you can easily make out that there is an oncoming train here, a locomotive. And in thermal, you see something which is in between the two. So depending on taking advantage of the spectral band, one can deploy multispectral sensors and derive the best of these spectral bands and merge them together. On the SWIR side, this is an example of a test we had conducted. We keep conducting these tests. This is just an example for people from artillery. They would know, from the School of Artillery, Devlali, we had, this example is from there. We had conducted on the outskirts test of our shortwave infrared solution. And what you see on the left is a very hazy image or a very hazy environment where the visibility was not more than 4 to 5 kilometers. And after that, it was hazy. And what you see on the right is, in that scenario, 21 kilometers away, we could see the Cadet Hill of School of Artillery very clearly visible. And probably you can see the sheds over here from 20-kilometer distance, and which is, the best kind of example one can give for shortwave IR and how it could enhance the capability. It is definitely something which is supplementing the existing sensors of the sensors which are already there, and together deployed with the visible and day, the shortwave IR further enhances this capability, especially during fog and haze. This is an example of how we improve the capability of existing sensors. What you see on the left is what the camera is seeing. If you image from a camera, this is what it will see. But on the right, what you see is the enhancement done by our algorithm, which is deployed on our end device. These are not something which are processed at the back end, but these are enhancements which are present on the sensor head itself. The defog algorithm, which removes the entire haze, and this has been demonstrated on several occasions. This is an example of low light performance. The left side, of course, is a video which is taken from YouTube. But what you see on the right side is the enhancement, the output of our enhancement algorithm that works on the video. So the entire video is not picked up from YouTube. It's just the left-hand example that is picked up. And what you see on the right is our algorithm working on the enhancement of this image. And you can see clearly the difference between the two. So basically taking advantage of the fact that the sensors are capturing this information, being having the high dynamic range capability, we are working on algorithms to extract the relevant portion of the imagery and trying to show that which makes sense. Yet another example is the multispectral fusion capability, where you can see on the top right, it's a day channel, the bottom right is a thermal imager, and what you see on the left side is a fused picture between the two. As you see in the night, thermal imagery, we know it does not give color. So we take advantage of the visible and the thermal imaging band and fuse the picture together to get the required information, that is the color of the signal. And so these are some real life examples where these systems or the multispectral and the fusion capabilities help solve problems. Thereafter, we have deployed examples of multi-sensor data fusion, where we have the capability, you can see on the left, this is a ground surveillance radar, which is coupled with an EO. The radar picks up targets at long ranges, and the EO does a slew to queue. And apart from that, we have other sensors with which we have integrated and are able to perform the data fusion to make sure that the user sees a common operating picture. Even if all the sensors are picking up the same target, it is the command and control which makes sure, or the fusion capability that ensures that the user is not cluttered with multiple information. He sees only one target. What we also have is a command and control solution to enable this, which is called SPIDER, Perimeter Intrusion Detection System. And it has the capability to integrate multiple sensors, heterogeneous type of sensors together, and give a common operating picture. It has video wall, and it has all the other workflows that the user currently has. More manual workflows are all automated as part of the SPIDER. Now, this gives an ability that even in areas where sensors are deployed individually, we can network them together over the fiber or the radio backbone and give a common operating picture at the headquarters. And what I mentioned before, the 24/7 power autonomy solution, we are providing along with our system various other enablers, like giving the sensor a 24/7 operation capability, so that you are required to charge only opportunistically when you are having a genset on at a particular area. That's the time where your batteries also get charged in the same process. You don't have to keep the gensets on all the time. Similarly, we have done aiding by solar panels, where we have deployed solar panels to charge the batteries during the day, and they sustain it over the overnight period without any operator intervention. There's power available all the time. The sensor is operational 24/7. And this can also be unattended, therefore. And we also have fuel cell based solution, which are providing true 2 kilowatt power, instantaneous power when the need arises. Other solutions that we have seen around are the ones which have a very low instantaneous power capability, and they charge the battery, and then further sustainment is through the battery. But this is one high power solution where you can charge the batteries much faster in a much smaller time than doing it over a period of time. Some of the products that we are working on, like in the earlier slide, I showed what products we have worked on, what capabilities we have. These are some of the products that we are working on. We are working on high definition sensor systems now for future requirements. We are working on sites for vehicle platforms. We are working on remote weapon station. We are working on ballistic computer-based sighting system. We already have a legacy for having been working in the weapon systems area. Ballistic capability is inherent to our DNA. And from that perspective, we are looking at combining in the night vision devices the ballistic capability inbuilt to provide the user a more accurate way of targeting. Thereafter, we have auto target tracker for tank. That is something that we are working on. As you know, many of you all know that we have been working on T90 ballistic computer replacement for quite some time. We believe that the only way to put an auto target tracker is the right know-how of the ballistic computer that we have gathered over a period of time. And we believe that with our capabilities on the night vision, as well as the ballistic computer development, we'll be able to provide an indigenous solution of auto target tracker in the existing T90 tanks without changing the gunner's sight or without changing the commander's sight. I mean, this would be kind of a low cost upgrade where a very small delta change would be involved. And thereafter, looking at users' requirement in the FOs, we have worked on, or we are working with a partner on aviation goggle. And we have a product in this regard, which can be used for all the retrofits of earlier helicopter programs. And this is a twin tube binocular device with a unity gain and with a very high FOM tube, which can be used for helicopter pilots for nighttime operation. To do all of this, we have a complete in-house design capability. Capabilities like these are not built overnight. As a company, we have been an R&D house first, a manufacturing setup later, and we believe in doing our complete R&D end to end. So this encompasses various, even if you see the subset of electro-optics, there are several domains that have to be combined together in order to reach to a final end product. Thankfully, due to our legacy on electronics and other systems, we could, 8 to 10 years ago, when we decided to go in optronics, we could harness those capabilities and build up the incremental electro-optic or optical design capabilities that were required and come up with products at the pace that you have seen. Just to cover this entire story, apart from the development capability, what is also important is scaling up to high volume. Now, we have been talking about it again and again because this is a very important aspect that while majority of the time, a lot of R&D remains at lab level because the industrialization or the productionization of that is something that does not happen in the way intended. Therefore, many technologies take time before they come into full-blown production and they reach to the end user. Because finally, the purpose is not served until the technology that has been developed is in the hands of the user and being used. And towards that, the industrialization or the productionization phase is very important. This is where a lot of failures can happen if not done right. Now, we have taken steps in this direction to ensure that we have the right clean rooms, we have the right scale, we have the right tools, like we have ERP, we have a product lifecycle management solution, version control methods, all ensuring that we are able to provide an end-to-end solution starting from the concept design to the production grade deliveries in the shortest possible time frame. These are some of the test and measuring equipments. We have a variety of them which are used both for R&D as well as production. And the volume claims that we make comes based on the confidence of the equipment and the skilled trained technicians that we have with us. And this gives us the confidence to plan and claim that we are able to provide 800 to 1,000 systems per month. Even on the image intensifier, we have a complete end-to-end test capability and assembly capability, both for the equipment as well as the tubes themselves. So to summarize, we are in line with the latest technology trends in the military EO domain. We are focused towards development of new generation EO products and solutions required for the Indian market. Now we are working on, as I mentioned, we are working on several development programs, which we see as a potential growth engine. Apart from that, as I mentioned, we have our high volume production capacity that serves the purpose of bringing this cutting edge technology to the end user in a very short time. So with this, I'll end my presentation. Thank you for your patient listening.
Thank you so much, Mr. Vinod. That's a great talk that you gave about the capabilities. We are very well aware of it. I got a first-hand look when I visited your facility, both at that end and also the other day when you showcased a few equipment here. So yes, there's great work that is being done out there by you all. Our compliments to you. You have been offering solutions which have already got inducted and some more are very forthcoming. I'm quite sure all the best in the ones that are going on. And your future projects look very interesting. I'm quite sure the Armored Corps, all those who are on board, would be listening very carefully to the solution that you offered. And of course, not only you, I would reach out to everybody out there that all those future projects that you're working on, these technologies that you're working on, do share them with us, do reach out to us. Probably we can align together, all of us, to be able to develop what could tomorrow be used by our soldiers. So thank you very much, Mr. Vinod. So I think that's it. It has been a very engaging session, one of great learning for, especially for all of us here at Army Design Bureau, to be able to get a comprehensive scan of the ongoing work in the indigenous and the world industry, the technologies being developed in-house, the future of the night vision and electro-optical technologies in the world, the solutions for field maintenance and testing. As I said, it's a huge problem for us. And last but not the least, the developments that are being done in our industry where we can actually look at partnering with them. Just to sum up, we know that the envisaged contours and trends of future warfare in this particular field of night vision and electro-optics industry is continuously evolving, and there is no, I think you would all endorse when I say there is no place to hide on the battlefield now, it seems. And that spurs me on to now look for counter EO technologies to be able to get away from this omnipresent sightings. So leveraging technological advantage remains central to our perspective plans, which we undertake for force modernization. And we will focus on our capacity enhancement and capability development in these particular domains. We in the Indian Army believe that technological infusion is commensurate to contemporary development and needs to remain an enduring pursuit. And we saw a demonstration of that on the Army Day. So be it swarm drones, be it AI, be it quantum, be it night vision technologies, we need to remain contemporary. And the only way we can do it by building an interface with our industry and academia. And timely infusion of these is very, very critical. Otherwise, we'll be left behind both on the technological curve and also the cutting edge in the battlefield. I'm sure that these insightful deliberations over these 2 days shall enable us to leverage this technology in the best possible manner for the Indian Army. So may I now thank all the participants for their views, insights, knowledge sharing, solutions, and of course the recommendations that you have put forth. We will take them back with us and see how we can move forward on these. On behalf of all of us on this panel, I would like to thank St. George IMR Combined, General Srivastava, General Arora, for having given us this opportunity, and we look forward to some interesting sessions ahead. which I'm told now are open immediately after this talk for logging purposes. And the next session will definitely start at 14:30 hours. So we look forward to those sessions. And thank you very much to all of you, and take care. And nowadays, stay safe, please. Thank you very much, and all the very best.
Yeah, it remains for me to thank Jan Kirti Johar, who has been having a very extremely busy and very purposeful, I would say, engagement in the last 2 days. We all saw a very visible demonstration. He has been talking about it. I also mentioned it. And he was the appropriate person to have headed this very important session, because he is at the forefront, spearheading the engagement with industry, academia, and everyone else involved in taking our country and our capabilities forward. So thank you so much, Kirti, for having chaired the session. And I also thank all the other participants. Now, this session has given us a very good perspective to give us a threshold and a benchmark as to where we are and what we are envisioning our future requirements to be. So the coming sessions, which are going to be about our stating our requirements, whether in the sub-conventional domain or platform-centric, and our R&D efforts. That's the last session. So all that will get now contextualized. What we have seen are the global standards, and we are very glad to see and hear for ourselves, actually visually see for ourselves that we are in step. We are absolutely in step with everything that is happening around us. It's so reassuring. So thank you so much, all the distinguished panelists, and thanks, the chair. All the best.
Also, I want to give this chair